Defining Ethernet standards. Ethernet is far and away the most common type of LAN standard used by today's organizations. It is a scalable technology, but to get the most out of Ethernet, devices, computers, and other hosts should be compatible. This means knowing the various Ethernet standards is very important. Certification ready. Can you identify and describe Ethernet standards? Objective 1.5. Ethernet is a group of networking technologies that define how information is sent and received between network adapters, hubs, switches, and other devices. An open standard, Ethernet, is the de facto standard and has the largest share of networks in place today, with token ring and FDDI filling in the small gaps where Ethernet does not exist. It is standardized by the Institute of Electrical and Electronics Engineers, IEEE 802.3, developed originally by Xerox. It was later championed by DEC, Intel, as well as Xerox. Now, Ethernet products are offered by hundreds of companies, such as D-Link, Linksys, 3Com, HP, and so on. Computers on Ethernet networks communicate by sending Ethernet frames. The frame is a group of bytes packaged by a network adapter for transmission across the network. These frames are created and reside on layer 2 of the technology model, which is covered in more depth in the next lesson. By default, computers on Ethernet networks all share a single channel. Because of this, only one computer can transmit at a time. However, newer networks with more advanced switches transcend this limitation of Ethernet and is covered in more depth in lesson 2. IEEE 802.3 defines carrier sense multiple access with collision detection or carrier sense multiple access with collision detected, CSMA CD. Because computers on a default Ethernet LAN all share the same channel, CSMA CD governs the way that computers coexist with limited collisions. The basic steps for CSMA CD are as follows. Point 1. The network adapter builds and readies a frame for transmission across the network. Point 2. The network adapter checks if the medium, for example, twisted pair cable, is idle. If the medium is not idle, it waits for approximately 10 microseconds. This delay is known as the interframe gap. Point 3. The frame is transmitted across the network. Point 4. The network adapter checks if any collisions occurred. If so, it moves on to the collision detected procedure. Point 5. The network adapter resets any retransmission or counters, if necessary, and ends the transmission of the frame. If a collision was detected in step 4, another procedure called the collision detected procedure is employed. The network adapter continues transmission until the minimum packet time is reached, known as a jam signal. This ensures that all receivers have detected the collision. Point 2. The network adapter increments the retransmission counter. Point 3. The network adapter checks if the maximum number of transmission attempts was reached. If it was, the network adapter aborts its transmission. Point 4. The network adapter calculates and waits a random back-off period based on the number of collisions detected. Finally, the network adapter starts the original procedure at step 1 of the CSMA phase of the CSMA CD process. If an organization utilizes wireless Ethernet carrier sense multiple access with collision avoidance, CSMA CA is employed. CSMA CA is a network multiple access method in which carrier sensing is used, but nodes attempt to avoid collisions by transmitting only when the channel is identified as idle. When nodes do transmit, they transmit their packet data in its entirety. CSMA CA is particularly important for wireless networks, where the collision detection of CSMA CD is unreliable due to the hidden node problem. Devices on an Ethernet network must be compatible to a certain extent. If you are using an Ethernet switch, a computer's network adapter must also be of an Ethernet type in order to communicate with it. However, unlike some other networking technologies, different speeds can be negotiated. For example, suppose your switch had a maximum data transfer rate of 100 megabits per second. But your network adapter only connected at 10 megabits per second. The network adapter would still be able with the switch, but at a lesser rate. The various speeds of Ethernet and the cable media they use are defined by the various 802.3 standards listed in table 1.2. Although 802.3 by itself is generally thought of as 10 megabits per second, it is further broken up into various subgroups, as shown in the table. Table 1.2, 802.3 Ethernet standards, 802.3 version, data transfer rate, cable standard, cabling used. These are all 802.3 J, 10 megabits per second, 10 base F fiber optic, and so on. All of the 10 megabits standards listed are a bit slow for today's network applications, but you might find them in some organizations and in other countries outside the United States. Of course, a good network administrator can make even 10 megabits per second networks run quickly and efficiently. In fact, an efficient 10 megabits per second network can easily outperform a poorly designed 100 megabits per second network. The 10 gigabits per second standards are much newer as of the writing of this book, and therefore are much more expensive. Currently, 1 gigabits per second connections for clients and 10 gigabits per second connections for network backbones are common. The most common cabling standards used today are 100 base TX, 1000 base T. Keep in mind that new standards are constantly being released by the IEEE. 10 megabits per second is typically referred to as Ethernet. 100 megabits per second is known as fast Ethernet. And 1 gigabit per second is known as gigabit Ethernet. 1 gigabit per second is known as the gigabit Ethernet. Lesson 1, page 32.